Welcome to Embedded.fm. I'm Alicia White alongside Christopher White. This week we are speaking with Windell Oskay, co-author of the Annotated Build-It-Yourself Science Laboratory and co-founder of Evil Mad Scientist Laboratories. Now before we get started to talk to him, I want to remind you that at the end of the show last week, we did give out a discount for small batch assembly, Bob Cogshall's company. So if you want, 20% off, you got to go listen to the end there.
Hi, Windell. Thanks for joining us today.
Thank you.
Could you tell us a bit about yourself?
I started out as a physicist, and I got my PhD at the University of Texas at Austin, working on basic quantum mechanics experiments, doing quantum optics and making ultra-cold atoms. And I went on from there to do a postdoc at NIST in the Time and Frequency Division in Boulder, Colorado, where I worked on atomic clock projects for 3 years. And after that, I moved out to Silicon Valley, started working for a small company designing and building scientific instruments. And during that time, I had some free time for the first time in my life where I wasn't actually required to be doing anything particular in the evening on the weekends. And this had some consequences, which is that some of my hobby projects kind of got out of control. And about 7 years after that, I quit my day job and became full-time at Evil Mad Scientist, where my partner Lenore and I design and build and sell strange little devices that we make.
Well, there are all kinds of strange little devices. The EggBot and the watercolor bot. And you also resell a few things from Adafruit.
We do, and a few other kitters that we particularly like. So it's a curated collection. We're not trying to be the next DigiKey, but we have some wonderful devices that people make that we do resell.
So what's your favorite device that you guys created, that you and Lenore created?
That's a great question. One of my favorites is one of the particular EggBot models called the EggBot Pro, which is a big chunk of machined aluminum that is great for drawing on spherical objects. Another one of my favorites is the Discrete 555 kit, which is a collaboration with our friend Eric Schlepfer. And this is a 555 IC, but instead of being a single chip, it's actually built of the original 26 transistors and a set of resistors that make up the original 555. But it's two N3904s and 3906s, and you solder them together, and you build a working 555 out of it.
And so you explode an integrated circuit into something you can actually build.
Yes, we call it a disintegrated circuit.
Disintegrated circuit. I think of Star Trek with that, They disintegrate and then they go to a different planet. The EggBot is a CNC machine at its heart, isn't it?
It's a very basic, friendly CNC machine. The EggBot actually is another one of our collaborations, and this time with the artist Bruce Shapiro, who made the first EggBot around 1990. So the whole project is 25 years old now, and he approached us about 5 years ago to start making friendly kit versions of it. And the EggBot is, yes, it's a CNC machine, but it's a great thing for people to begin learning on because no matter how hard you try, you can't really hurt yourself with a Sharpie pen.
I don't know. I can try pretty hard.
And, in the other room, we're using spinning carbide, and that can hurt you pretty quickly. So
what did it look like in 1990? Because it's easy to conceive how to build such a thing now. But.
Well, yeah. So it had stepper motors and masonite, and from the pictures we can tell loose wires going everywhere, some glue, hose clamps, little rubber stoppers, and so on to hold the eggs. And a lot of the DIY and homebrew versions still look like that nowadays, but they are. There's also the very fine versions that we make, trying to make elegant versions of it.
And your elegant versions do work on a spherical object. I mean, when I look at CNC machines or pick and place machines or laser forges or milling machines, all these things, it's a 2D thing that may become 3D if you go enough 2D layers down. But you're working on spheres. That's weird. Why?
It's not really that weird. If you think about the basic machine tools that we use, you might categorize them loosely into two sets, which would be mills and lathes. And already one of those things is in cylindrical axes, that you have your distance, your radius, and your length along perpendicular to that radius. And then you have your XYZ, but the EggBot is actually in spherical coordinates, which is very unusual. And so rather than having a axis like a lathe where you have one part that moves in a straight line, the EggBot actually has two things that move in circles. It's easy to think of these on a globe in terms of latitude and longitude. We're already used to thinking of angles and spherical coordinates. And to be perfectly fair, it's really a 2D machine. It just has that latitude and longitude axis and a pen up, down. So it's not entirely dissimilar from a conventional pen plotter that works in 2D and X and Y with a pen lift, pen down. And we have these going back to the pen plotters of the 1960s, and then back before then to the auto pen machines, which were mechanically recording devices with hardly any electronics except spinning the wheel.
I mean, that makes sense. You can only draw on the surface, and so therefore it must be a 2D eventually. But those spherical coordinates, I bet, trip a lot of people up.
They do. And one of the funny questions we get about this, and it's a recurring question, is I have a flat thing, and I want to wrap my flat design around a sphere. I want to put my drawing on a Christmas ornament, and I don't want any distortion. And I just got to smack my head when I hear that question, because I think everybody's had that experience of looking at a map and seeing, wow, Greenland's as big as Africa.
Right.
And then looking at a globe and saying, wait, what? And saying, oh, Greenland's the same size as Argentina, maybe? And it's...
many projections to choose from.
Yeah, and I think a lot of the artists that I've actually talked with and worked with, they get that intrinsically because great artists have an unbelievable grasp of geometry at a fundamental level. They feel spheres and arcs and things. They know how those things interact. But some other people who are just getting started or aren't used to thinking in that framework, I have to explain that if you take this map of the Earth, and you try and wrap it around a sphere to make a globe, you're going to crumple the Yukon and Antarctica, and that's distortion.
But I want my flat 2D thing to go on this round 2D thing. I can see how, I mean, of course, I understand the distortion effects, but I bet you have that conversation a lot.
We do, and there's all kinds of ways we can approach this, and we've thought about trying to make a software model that allows you to take the thing and apply a 2D drawing so it will be locally flat. Because, I mean, if you start out with a small area of a sphere, it's a pretty good approximation to flat. You know, we build houses and stadiums and things that we model the ground as flat beneath them. That works. But once you try and do more than, say, 90 degrees, things really fall apart.
It's probably one of those things is you should suggest, well, try these various things and see what looks best. Because a sphere is one thing, and an egg is, forget it, right?
And if I had to guess back when I was studying to be a physicist, what I'd spend my life doing, explaining to artists how to make things look good on a sphere would not have been one of them.
A lot of people we know who get physics PhDs.
Or other degrees in physics.
Or astrophysics PhDs or master's degrees in physics, yes. They seem to spend a lot of their time writing software. Why is that?
There's a few different good reasons for that. One is that fully half of the physicists are theoretical physicists. They're theoreticians. Their job is to model things. And a lot of that is pencil work, but a lot of it is computer work too. And there are computational physicists, and that's a small set. But when I talk to people who are astrophysicists or who are quantum physicists but are theoreticians, they will spend a vast amount of their time trying to come up with good models and then running those simulations. These people know Fortran, and they borrow time on Craze.
Yes.
that's fine. I'm not one of those people. The other half, the experimentalists, and that's how I identify myself, are people who have spent their life designing experiments. And designing experiments means that you do spend a lot of your time actually designing hardware, and it's how I learned electronics, and it's how I learned to do mechanical design work. I learned to do mechanical design work because I needed a thing that does this thing. And this actually gets back to a thing from the book, which is that the process of learning how to make things is important, because if you are ever an experimental scientist, your job is to measure a thing, and it doesn't matter how much new design work, how much software, how much hardware, how much new technology that hasn't been invented yet is required in order for you to make this measurement. Your job is to overcome that obstacle to make the measurement, and it doesn't matter how hard it was to get there. Usually, how hard it was to get there is just a footnote in your paper about the thing you actually measured.
I think all of CERN and the Large Hadron Collider has stood up and is cheering loudly out there. And if you are, please email the show. We'd like to talk to you.
Well, outside things as large as the Large Hadron Collider, if you're working in a lab, it's a different experience than being a professional engineer where you're building something and you've got the resources of a company behind you and you've got technicians and double E's and a whole team. It's interesting to hear you say that, because I'd kind of forgotten that in a lab situation, it's up to you pretty much. You might have some assistance from, a grad student or somebody else on your team, but you don't have, you kind of have to do everything. So it's kind of like being at a startup where you're the only guy doing electronics. You kind of have to learn a lot of things.
The
only
and that's person.
Yes.
Sorry. Go ahead.
I'll just cut that out.
No. Go leave that.
But it like you're saying, it's a great way to learn because you're forced to. You don't have a lot of things to fall back on. So,
and that's the fun part of a really small startup. But it's also, at some point, you get to, well, how do I go on from here? The problem seems insurmountable when you have to design all of your own equipment, unless you've learned to break it down. Which I guess is the point where we actually talk about your book. Will you give us the elevator speech for your book?
Absolutely. I had this book when I was a kid. I discovered this in about 5th grade when my classroom went on its occasional field trips to our school library, and our librarian was teaching us about the Dewey Decimal System and taught us where the science books were in the library. And so I already knew by this point I wanted to be a scientist when I grew up, and I went and I browsed through this section, and I came across this great book there titled Build It Yourself Science Laboratory. And this is a book from 1963, and it was written by a guy named Raymond Barrett, who had been the education director at OMSI, the Oregon Museum of Science and Industry, for 22 years. And he had previously been a school teacher before that. And in his first few years at OMSI, he wrote this book. And the book was actually a collected set of mimeographed lesson plans originally.
Those are the purple copies.
The purple
the
ones.
Mimeograph is makes
Spirit
the purple,
duplicating, yes.
The special smell copies.
So Raymond Barrett had started out making this set of lesson plans, and he had offered this sort of by mail order to anybody who wanted to buy a copy, and they had sold some thousands of sets of these mimeographed lesson plans to educators all over the country. And this was really a different era. This was a time when there wasn't much resources available for doing hands-on science education for people who didn't have a budget and resources and materials and a laboratory already set up. So this wasn't necessarily designed for at-home use, but for teaching science classes. But it was how to build basic scientific instruments to do your own basic experiments at home in chemistry, biology, physics, astronomy, and meteorology with basically stuff you can find at your hardware store and the corner drugstore. And the Doubleday company heard about this set of mimeographed lesson plans and commissioned him to make it into a proper book, which he did. And he got an OMSI staff artist, Joan Metcalf, to illustrate the book for him. And then some years later, that was when I came across it. And so this book was from 1963. It was already old and grungy. and wonderful, of course, by the time I came across it. And I checked it out from the library a bunch of times, and I did a whole lot of the experiments. So after that, I sort of forgot about the book for a long time. And it was around the year 2006, 2007, after I'd moved to California and working for a little scientific instruments company. And I sort of remembered that I had had this book as a kid. I'd had this great science book. And eventually I kind of flashed on what the name of the book was. And I managed to locate a copy used through the internet. And I got a copy. And to my great shock and amazement, it was actually as good as I remembered it. And that really caught me off guard because, I mean, there's all kinds of, was that red fire truck I had in 5th grade also that great? I don't think so. But the book really was. And I sort of gradually realized as I talked to people about this book that almost nobody had heard of it. And this kind of baffled me. And I'm not sure what all the reasons for that are. One of them is that it was long out of print. Another is that because I had grown up in Oregon, and this was a book from the Oregon Museum of Science and Industry, and the teacher had been in the Portland school system, it's possible that just every school there had a copy of it, and that's what I would expect across the country, but maybe it wasn't really that well distributed. Anyway,
it is a science book, and there is an element of danger in it, which I do want to talk to you about. And it is a special book. I mean, it isn't a book that you just go up and just pick up and read. It isn't Geology 101 or Geology 8th grade. It's a meta science book in some ways.
It's not a textbook. It's a book that is intended for people to read for fun, for people who are into science to find resources to learn.
Yeah, but it's building the science equipment. It's not necessarily doing the science experiments, at least on the surface.
That's true. And it's a funny thing because the book lists on the cover, the original book listed on the cover as well, that you can build these 200 pieces of science instrumentation. But what's actually much more interesting about the book is that every one of the pieces of instrumentation that you build comes with a set of questions to ask. And so the instrument is really a prod. It's a prompt for being able to start to investigate the types of things that you would investigate with that. It doesn't say, build a thermometer. Now, what objects are hot? What objects are cold? Is the stove hot? It doesn't ask that, but it will start to have ideas for more experiments that you can answer now that you have this piece of apparatus. And all in total, the book has about 2,600 open-ended questions in it, which are all questions posed without answers. And they're all posed to get you thinking and sort of train you in the ways of experimental science in general.
Well, for example, since other people don't have the book in front of them like I do, there is page 67. So we're a little ways in the astronomy and light section. It tells you how to build a refracting telescope out of 2 convex lenses, a mammalian or paper roll, toilet paper roll, and rubber cement, a little bit of cardboard and some paper. And it goes through what all this is, and it talks about lenses and whatnot. And, the first can you work like a scientist sort of theoretical question is the object that you see upright or upside down? Okay, that's pretty easy. We could figure that out on paper without ever building it. But the number 9 question, fill a sink or bathtub to a depth of several inches. Make waves by dripping water into the sink or tub. Can you arrange the light so that you can see the shadows of the waves? Can you make the waves bend? These rays are very similar to light waves. And you really start getting into how things work if you really went through these. Are there any questions in the book that aren't answerable?
I think there are, although I don't think I could name any off the top of my head. A lot of the questions are very simple questions, and a lot of them are ones that require a great deal of research to answer, not just in terms of doing an experiment, but sometimes just in terms of understanding the question. And some of them, I think, still aren't answered today.
We need a list of those.
It's in the book here. It's just a very long list.
Yeah. And it's all kinds of topics. It's, astronomy was one section, general lab equipment, although that was mostly chemistry. Electricity and magnetism, weather, biology. The biology ones were, I don't know, the chemistry ones seemed a little more dangerous on the surface, but the biology ones seemed like, wow, maybe just don't tell your mom what's in that jar in the fridge.
So this book was from the 1960s. So one of the biggest challenges in updating it was to preserve the original character of the book while also adding modern safety guidance, but also ethical guidance, because it was perfectly acceptable to do certain types of experiments to animals in the 1960s that would just be unheard of today. You wouldn't imagine the sorts of biology experiments. There's another book that I have, it was actually recommended by the author of this one, called The Living Laboratory. And that has a lot of experiments which are sort of the form, here, this is a rat. If you take out this organ, sew it back together, how does the rat perform differently? And I just can't imagine doing an experiment like that. I cringe a lot when I read it.
But somebody had to do that experiment. I'm glad we don't have to now. I'm glad we have online resources to tell us. But
we also know a lot more about certain things.
Yeah, that's not... on the other hand, I'm working with mice that have little probes in their brains. So I'm not working with them. I'm working on the gear that works with them. So it's not like animal testing has stopped, but hopefully we've gotten more humane about it, and we aren't trying to learn the same thing over and over again.
That's important.
So do you have any favorite projects? Actually, let me rephrase that. When you were a kid, did you have any favorite projects?
One of my favorites when I was a kid was modifying a microscope with crossed polarizers. So I had this set of protists that I was looking at, some pond water, or really rainwater collected in an old aquarium outside, and a drop of it under the microscope had all kinds of little fast-moving things in it, but they were transparent. They were moving fast. But there was a tip in the book about you could take crossed polarizers, so two polarizing filters, and you put them at right angles to each other, one in the objective assembly of the microscope and one where the light was. And with that, it would be a dark field except for where you had something inside that rotated the polarization. And the thin membranes of those protists sure scrambles polarization well. So it was kind of a primitive dark field microscope, but I did quite a lot of the experiments from the book, and it would probably take flipping through the book for a couple hours to identify all of them.
Well, that one's pretty good, and I found it, and here it is on page 216. And the Can You Work Like a Scientist ones, turn one filter while you hold another filter steady, what happens? So I assume eventually the lights go out and the lights turn on. But then cross several strips of Scotch tape on a blank microscope slide and see what it does under there. Scotch tape and polarized?
Yeah, it makes a really neat effect to actually get all kinds of bright colors showing up, because this is a little bit like how LCD displays work, that you take your polarization, you take some light which has random polarization, you filter it with one polarizing filter so that only a single polarization comes through. And then different bits of light are polarized differently depending on what happens to them, including, in some cases, a shift in color and so on. And engineers actually use this in analysis, or I should say, before they use computers for this, they often used this kind of analysis to test structures. If you build a acrylic model of a structure and you stress it between crossed polarizers, you'll see bands of colors where it is under more stress. But of course, when we have FEA, who bothers?
Well, actually, I got glasses made from optometrist, with sunglasses, and they were polarized. And whenever I moved my head, I got intensely sick, and they put it under their polarizer and found that the glass had been bent wrong. And you could see where the polarizing went in and out of phase instead of being consistent across my field of view. And it was really disorienting. You don't realize how much the polarization actually matters. It has to be consistent.
There's a really neat thing I learned in the last few years, which was that humans actually have the ability to see polarization with our eyes. Very faintly, very weakly, but there's a very subtle effect that if you know exactly what to look for, you can look at a polarized light source and identify that it's polarized. And this has that mixed blessing of once you know what you're looking at, you will always see it.
That's a very mixed blessing.
I may be misremembering this, but I think you can also... A physics professor of mine once took us outside and said if you look at the sky on a perfectly clear day, you can detect differences in the color of blue because of the polarization from different, as the sun goes through the atmosphere in different directions. I may be completely making that up, but...
I believe that because if I tilt my head in different directions as I look at the sky, the blues change a lot.
That's a different problem.
That is probably different. I actually don't know about the color of blue changing or not, but I do know that on a blue sky, that the light is very polarized, and that if you look at it through a polarizing filter or off of a reflection of something, you can definitely tell that it's polarized. Or if you know what you're looking for, there's this effect. I think it's called Heidegger's brush, but I may be misremembering the name slightly. That if you know what you're looking for, you can actually see it with your eyes, that it is indeed polarized.
Yeah, we may have looked through a filter. I can't remember. It was a long time ago, but it was kind of striking once it might have been pointed out.
So we've been talking about this book as your book, and you've been talking about it as Barrett's book that you discovered in the 5th grade. Can you sort that out?
Absolutely. So this book is titled The Annotated Build-It-Yourself Science Laboratory, and that is my book. The original book is just called The Build-It-Yourself Science Laboratory. And so what I've done is I've taken this original book and I have left it uncensored, but added a lot of notes and annotations to it in terms of footnotes, updates about where to get the materials nowadays, because it is not your hardware and corner drugstore anymore, and modern safety notes, and in some cases, new questions added and new experiments added in very slight cases. But for the most part, it's a matter of taking this old book and making it more accessible to the modern generations.
So what kind of annotations? I mean, safety makes sense. Ethics makes sense. What else?
There are... This was a fine line to draw because we wanted to leave the book uncensored. We wanted to be able to put in all of the old experiments, even if they could reasonably be interpreted as dangerous. If we start picking and choosing which experiments we leave in, now we really have full responsibility for that set and making sure that we are putting a safe set of experiments in the book. So in order to include some of the really awesome but potentially more dangerous ones, we definitely wanted to include everything, and that was the first line to draw. Second, we wanted to make everything safer. So everything in there today is at least as safe as it was in the 1960s. We haven't made anything more dangerous, certainly, but we have added some safety notes and things like that. But it's also a little bit like sometimes you flip through an old Shakespeare play and it's got annotations about what the words mean now. There's a few of those too.
Yeah. Did you get bored of having to write, please don't light yourself on fire all those times?
No.
I mean, there was a lot of, look, fire and hot glass and chemicals, don't be an idiot notes.
There were. But one of the things I did was to sort of make one long explanation about how to not be an idiot with chemicals and one long explanation about how to not be an idiot around glass, and then a separate note about how to not be an idiot around hot glass, because that really is a separate problem.
Yeah, how did you survive childhood without Appendix E safety notes?
Now, wait a minute.
Well, no, I mean, there were, yes, and you did a good job of corralling them into this space where you should read it through and then you understand the safety aspects of it. But it did seem like, well, how would you survive if you didn't figure some of this stuff out?
I think that our society has evolved to be a little more paranoid about kids in danger than perhaps it should be. I'm not saying I never stuck a fork into a light socket, but
I did. I did.
There were a couple of negatives there.
Yeah.
Go to the instant replay for figure out what that. Yeah. Well, that actually answers the question I was about to ask you: is how you feel about some of the changes in, allowing kids to experiment with things. Because when I was a kid, I had a chemistry set and it had actual chemicals in it. Not as many as my dad's chemistry set, which had actual chemicals that were radioactive in it, and and he's still around. And when I was a kid, I did a lot of stuff with Estes rockets and took the fuel out of the engines and put in other stuff. And I'm still here and have all my digits. So I don't know. I feel like we are, like you're saying, have become a little too paranoid, and I worry that people aren't learning through experience anymore.
Well, one thing you could say is that just because something is potentially dangerous doesn't mean it's always dangerous. And there's a lot of changes in society that sort of reflect this in sort of baffling ways, like not letting kids walk home from school even if it's just a couple of blocks. Or I saw a chemistry set advertised this year that's big advertising bullet point was no chemicals.
It's an empty box.
And I mean,
not at all.
So
danger contains water.
Yeah, well, you've seen the DHMO warning labels, so we know that story. I mean, I had the chemistry sets and I survived, but the chemistry sets with their, dozens of potentially dangerous chemicals if you eat them, and the chemistry sets with their hundreds of frankly really boring experiments that potentially show something if you're a dedicated chemistry student, it didn't necessarily have the right balance between excitement and danger. And I sort of understand why those things have gone away to some extent. But the argument just that, it's chemicals and we can't let these be around the kids, a chemistry set without chemicals, what were you thinking?
Well,
tell us how you really feel about that one.
Right. Yeah.
I never hurt myself with a chemistry set as a kid. The only times I had serious problems were in college, and under supervised lab conditions. I had 2 incidents where I got a little too much hydrogen sulfide in one case, and I think it was hydrogen sulfide, it might have been sulfur dioxide, one of the two.
I'm so glad you weren't my lab partner. My lab partner rocked. He kept me so safe.
We should have been under a fume hood, but they didn't tell us to use fume hoods.
Rob always took me to the fume hood if I needed it.
The worst one, though, was when I was in a lab where we were just writing stuff up, and somebody across the bench decided to pick up the squirter of acetone and spray it in my face as a joke because he thought it was water. So, yes.
Wow, you hung out with the bad kids in college.
That's like a really great example of what not to do in lab safety.
Yeah, exactly.
Yes.
It's a joke I remember from the movie Gremlins 2. There was a lab scene, and one of the gremlins grabbed a jar labeled "Acid Do Not Throw in Face." And you know what happens next.
Well, yeah, of course. So the book went quickly from what seemed like fairly boring stuff, like cutting milk jugs to make safety sinks or to make chemistry sinks in a reasonable way, and breaking light bulbs to get little test tubes, to bending glass over an alcohol flame, which that was the first time in the book I was like, oh, yeah, that would be fun. I don't care what the experiment is. Let's go bend some glass.
Well, it really wasn't for an experiment. It really was, you're going to be making some instrumentation. And one of the things we'll need to be able to do to make this instrumentation is bend the glass. And so here are how to make a pipette. Here's how to make a pipette with a big opening in the center so it can hold more volume. And here's how to make a T-shaped junction.
And you're blowing glass in some of these parts. And it says very clearly, do not suck. But yeah, you're actually fire hot molten glass making changes.
And that's why you need the safety warnings. And, the original book, it did have safety warnings, don't touch the hot glass. But the safety warnings were all understated. They were all, yes, that's true, but I got to tell you why, which is that you're going to end up with a third-degree burn if you actually do stick your finger on that white-hot glass there.
So in the book, there are red and blue annotations, and I think the blue ones are the originals and the red ones are the modern?
Yeah, so every experiment in the original book had two special little sections on it. One of them was labeled Safety Tips, and the other was labeled Can You Work Like a Scientist? And the Can You Work Like a Scientist question are these open-ended questions, and the Safety Tips were the original notes about how to do your experiment safely. And they were, very honest and straightforward, but they genuinely did assume that you're not an idiot and you're not living in a nanny state. And that's not always true.
Oh, yeah. For the saltwater rheostat, in which you plug your house current into salt water in order to make a DC current source.
Well, the salt
it says,
conducts well.
Don't touch bare wires. Don't reach into the wire or any way touch the sinkers. You will receive an electrical shock.
It's actually just a resistor. It's not actually a rectifier. So it's still AC. It's just less AC.
It's just less AC. Okay. I didn't actually read that one all the way through. So we're going to... It does say young experimenters never work with the rheostat unless your parents or teacher are present and give you permission.
Yes.
Now, was some of the intent of the book, you think, being able to get equipment that was not widely available into people's hands to work with? Because now, some of this stuff, you can just go on Amazon, I'll get 50 pipettes. But back then, it was impossible, probably.
If you live in most states, it's totally fine to just order your flask from Amazon.com. But if we have a lot of states in the U.S. now, maybe not a lot, I haven't looked up the current regulations, but there are states in the U.S. right now where it's basically not legal to purchase your own lab equipment without some special process to do so, or I'm not even sure to own it. And I find this baffling and wrong. In California here, I have a local store called Lab Pro that I can go to and purchase a beaker or a test tube when I need it. And
you can get those at Fry's and other hardware-y stores.
Yeah, and that's wonderful. But we do have so much more access to this stuff now than you would have all that time ago. But again, that's the real reason to learn to build stuff is not so much that you can't get a beaker. It's what if you need to build your own instrument that hasn't existed before? Right. When you need to build your own thing because you're an experimental scientist, you really want to have some general background on how to build instrumentation.
Yeah. And you do list in here where you can get uranium now, which I guess is no longer available at the local drugstore.
I don't think it was ever available at the local drugstore.
Plutonium, yes.
So I asked you what your favorite activity was when you were a kid. Having worked on this and having read through it and thought about these things, what is your favorite experiment activity build in the book? Or two or three favorites?
One of my favorites is the carbon arc furnace, just because it's so bat guano crazy, which is
carbon arc furnace.
So
anything with arc in it is going to be good.
I know, right?
Well, if it starts with carbon, it's even better.
It's
that's like page 21. That's early in the book.
Yeah, that's this thing where it goes from. Oh, and there is a saltwater rheostat involved. This is that thing where it goes from.
Yeah, it uses the saltwater rheostat to control the carbon.
Yeah, so let me describe this in accurate terms here. So you take two carbon rods. You might get those out of a battery, or maybe in modern times we ordered them as carbon welding electrodes from McMaster Carr. And you put those in a flower pot. You hook them up using a suicide cable to the wall, regulating the current with a...
Can we define that?
Oh, yes. A suicide cable is a lamp cord, 3-conductor with a ground wire clipped off and alligator clips on the other two.
Gotcha.
Aptly named. Okay. Suicide cable to the wall.
There's a term that doesn't appear in the book. I don't think it appears in the book. And then you regulate the amount of current that flows by using the saltwater rheostat, which is two loose wire ends attached to lead sinkers in a bowl of salt water. And the distance between the two sinkers in the salt water regulates the amount of resistance between them and can vary the amount of current that flows. The water gets hot.
Do not touch sinkers.
So now, the first thing you would say is this is insane because, well, what's stopping current from flowing should you trip? And the answer is only your circuit breaker on the wall of your house. So you want to use an isolated variac with a low amperage fuse on it when you try this, and maybe you want to actually use a separate variac instead of the saltwater rheostat. And then the other danger, notwithstanding the hot water danger and the intense heat that this produces, is that you're producing a light that's brighter than the sun to look at. That is an arc that is capable of doing welding. And I have an auto-darkening welding helmet that goes up to a number 13 shade, which is awfully dark. But you're supposed to use a number 14 shade when you use a carbon arc. And I went to the local welding store to try and find a proper number 14 shade, and they only went up to 12 there. So,
but it says here in the safety tips, protect your eyes by wearing dark glasses.
Yeah, and that's some of the original advice that is just understated to the point of being useless. So
yeah,
dark glasses are cardboard painted with.
My future's so bright, I gotta wear shades. Yeah, and in the modern safety tips, you do talk about protecting your eyes. And
and this can be
really bad.
This can be as cheap as one of those $1 eclipse viewing films that you can get, and all the telescope stores have those, and camera stores often have those.
That one doesn't have any questions.
It's because at the end of it,
you're so amazed.
You can't read the book anymore.
Or maybe it's just not really a good idea to do any experiments with that one.
Well, it's in the general lab equipment, the first chapter, which doesn't seem to have questions.
There is also a big set of questions at the end of the chapter.
Oh, I see. Okay. Where did the curtain rod come into that?
So this was...
because one of the safety tips is don't touch the curtain rods while the furnace is plugged in.
And if you hadn't read the experiment, I can see why you get confused. The carbon rods are mounted in hollow tubular curtain rods, which were common at the time, in order to provide the electrical connection to them.
That sounds like a great idea.
Yeah, so anyway, you can see why if we had to pick and choose what experiments were going to be in the book, you'd have to really think several times before putting that one in. And that really loses a lot of the character of it and a lot of the awesome of this old book.
Yeah. But what about adding experiments? I mean, quantum, all of the new science since 1963, there's so much.
They had quantum back then.
Well, yeah, but now we can do quantum experiments that make a lot more sense, even with, not super expensive equipment. I could see doing some neat stuff.
You certainly can. And there are some really neat things that have become available since then, such as LEDs and cheap lasers. And we have such incredible instrumentation at our fingertips. You can go to Adafruit or SparkFun and buy a dozen different sensors for $100 and measure all kinds of things in incredible rate, in great precision, and with almost no effort. It's really staggering how easy it has become to measure physical quantities in the modern age. We have small devices that provide us with GPS and atomic clock locked time. We have devices in our pockets that have capabilities of supercomputers that didn't exist in 1963, and you could go on for a long, long time. I've toyed with the idea of producing a second volume or a companion to it, say, modern experiments for the Build-It-Yourself Science Laboratory or something like that. But it turns out that a book is really an enormous amount of work. And
really? I had no idea.
I'm sure you had no idea. You've never had any personal experience with this, right?
And only an idiot would write a second book, I believe is the phrase.
I sort of kept it as a mark of pride for several years there that I had not succumbed to the desire to write a book.
And then you fell. And
there's a sense in which I was blown away by the amount of work that it took over the course of, a year and a half to get this book out there. I had an assistant who worked for me all summer 2014 who did all the heavy lifting of scanning the original book and proofreading the OCR from garbled text to real text. And we cleaned up all the original illustrations one pixel at a time. And, after that, I did round after round after round of going through it and editing, trying to keep all the text original, but correcting little errors, minor rephrasing, and trying to make sure that the set of annotations was self-consistent and useful and helpful.
Do not touch curtain rods.
Yeah, exactly.
You needed something a little more useful than that.
So even after all that, I was sort of blown away by the amount of work that this was. And there's a very real sense in which I didn't even write the book. I mean, this was an existing book that I refurbished and annotated. But now, one asterisk on that is that if I were writing the book, I'd have a lot more freedom to play with what exactly was presented, and I wouldn't have to wring my hands about what the right line to draw is on certain types of things and how to present certain types of things in such a way that they can be safe, because I know how to tell these stories. There's all kinds of great, easy-to-do experiments nowadays that I just love to throw in there. One of my favorite demos is take a strong neodymium iron boron magnet and you drop it down a 6063 aluminum tube, which is got wonderfully high conductivity, and it falls ever so slowly down. And this isn't in there. And why isn't it in there? Well, you can get a ceramic magnet back then, but the kind of magnet you can get your hands on for a couple $2 right now is spectacularly better than anything that was available then.
Well, then they don't, we were talking about quantum, they don't do any of the light, is it a particle, is it a wave sorts of experiments that I found really fascinating. I was like, physics, this is weird.
Well, you were talking about the bathtub, so there's some hints, but
yeah,
they're only opening the door.
Not as simple as a double slit experiment.
Nope. And double slit's great. And, with a $3 laser pointer and a couple of lines, you can do that. And the amount of spectroscopy you can do with an old CD and or just, the little hologram on your credit card. I pull that up sometimes, like, what kind of light is that? I can tell that's a fluorescent or LED or sodium or mercury just by looking at my credit card.
Yeah, there's a lot of stuff you can do in astronomy now that couldn't be done
absolutely
even 20 years ago with millions of dollars of equipment.
And yet you have fewer dark skies, so you have to choose your astronomy.
Yeah, but yes, you do have to choose, but there's definitely things you can do that don't require dark skies.
So you had mentioned the build your own telescope experiment, and you can build your own telescope, but it's just, telescopes have gotten so good and so inexpensive in the last couple of decades that...
Well, it was a 2-lens refractor with
it's
iffy alignment.
It's kind of junk even if you do it perfectly.
Yeah.
I bought a 8-inch Dobsonian telescope this year, and it was $400, and the stuff you can see with that just floors me. We went out to the hills above San Jose in August this year and got to see Neptune. And I saw Neptune with my own eyes. That's pretty neat. And as an experience you can have for a few $100s, and that's just incredible to me. And the $50 or $100 telescope you can buy now, a 4-inch reflector, is just incredible.
How did you end up writing the book? Did you go to Make and say, I have this idea? Did somebody come to you and say, you know what we need? How did it start? Tell me about the book proposal.
So we are friends with Dale Doherty, the founder of Make, and he had come to visit us, and we had lunch with him one day, and we were showing him around. And one of the things I showed him when he was visiting was this old book I had. And I said, I have this old book. I think this needs to be in print again. And he looked at it. He snapped a photo of it. I don't know if he got his own copy or something, but he wrote back to me shortly and he said, yes, we should make this happen. And then it had to have been 2 years later that I wrote to him again. I said, I'm ready to do this now. And he assigned me an editor. And the tricky thing was, and I guess what really took that couple of years was deciding on the best way to approach it. And the trivial approach would have been we just scan it and reprint it. The book actually lapsed into the public domain, and that has had some interesting consequences. One of them is that the companies that scan and print old public domain books and reprint them have already scanned and reprinted this. So between the time that I rediscovered it and the time that we made the annotated edition, it actually became possible to just purchase a new copy of it. And it...
Oh, you were like mid-edit at that point and went, oh...
A little bit, but I also knew immediately what they had done, and it didn't really rattle me. I bought a copy. It was $40 on Amazon, and it's one of these, direct-to-print things, and it's just exactly the same as the original, down to the page numbering and everything, except that it looks like it came off of a fax machine.
That makes sense. Yeah.
And it's got that sort of 200 DPI scan crappy quality to it, and
some of these images You need the lines. You need them to be pretty precise. They were not big to start with.
So my assistant spent about a month of last summer in GIMP with the pencil tool.
Yeah.
And we had as our source material the scans of an original book. And we trimmed it, we edited it, we tried to make those neat. We retypeset all the text in the drawings and found the original font. And it was... a heck of a lot more work to get the graphics looking good than I had anticipated. It was a funny part of the process.
Were there any that you just had to say, forget it, we're going to do this one from scratch?
That's a great question, and no. But there were two cases where I did have to make a drawing. And one of the cases was the text referred to a drawing that just wasn't there. And I realized, reading over this like 5 times, wait, what's it talking about? There's nothing there. And I eventually realized, oh, I have to do this myself. And I made the drawing and I put it in. And I'm not telling anybody which one it was, so it's a challenge. Nobody's yet figured out which. That should be the...
That's good. That's a nice litmus. It means you really...
That should be the prize, right? Find the new illustration. The other is, there's one experiment in the book that just never would have worked. It was actually blatantly wrong.
Oh, I love this.
Which one?
The project was called Simple Oscilloscope. And what it was a old neon tube of a specific size, a neon light bulb. And it's the one that has a saucer shape to it, or one of the ones that has a saucer shape to it. And if you put current one way, it lights up half the bulb. If you put in the other way, it lights up the other half of the bulb. And that's true. And when you put AC on, it lights up both halves, and it gives that pleasant glow that everyone's expecting to see when they look at the neon light bulb. But they were saying that you can hook this up to low voltage DC circuits and see which way your current is flowing, and sort of use that as a sort of a quote oscilloscope, I guess, kind of. But oscilloscope's a thing that records a thing versus time, or maybe X versus Y. And so it didn't really seem very oscilloscopy to me. And the other thing is that it's a neon bulb. It requires like 90 volts to light up to start with. And
that's a fair amount of DC.
And so somebody pointed out this to me, and I didn't actually have this bulb, but I'm fortunate to have a great set of hacker friends in the area, and I put out a call, does anybody have this light bulb or know where I can get one? And someone... John Foote actually responded and said, yes, I have one of those. I will try this. And we looked at that. He tried it out. Sure enough, it takes like 90 volts. We looked at the data sheet. We were able to find the original data sheet for this light bulb. It also says it needs like 90 volts. And at this point, I sort of smacked my head and said, this is not going to work. So in the keeping with the correct spirit of the book to not, take out an experiment, what I did was I moved it to the appendix, and I replaced it with a new experiment in the text that does the actual same function. The experiment, of course, consists of 2 LEDs and 2 resistors back to back, and or is it 1 resistor? Anyway, back to back, and with that, you can actually see the direction the current flows in a low voltage circuit. And I think I may have renamed it as well. But it was kind of neat. I got to put LEDs in the book after all.
It needs someone to go through the book, sort of like Julie Powell's Mastering the Art of French Cooking, where she cooked everything in Julia Child's books. I can see somebody doing that with this book on YouTube and then discussing each one of those science questions. It would be just an awesome series. And if you did it all in a year, it would be an awesome and exhausting series.
It would be, and I wish I had time to do that. And I honestly expect that if I did every experiment, I would find a couple more things that don't work as well that I haven't noticed so far.
How many of them have you done?
Probably a few dozen.
Okay.
And that's post-childhood? I mean, did you do a lot of the experiments as you annotated the book?
I did not.
It's a lot of work to write a book.
It's a lot of work.
Who was your intended audience as you worked on it? Did you have somebody in mind?
Not a particular person, no. What I really hoped was to sort of replicate that experience that I had as a kid discovering this awesome book full of great experiments that were actually within my reach to do, and hoping that a new generation of kids would be able to have that same experience. And the problem, of course, is that if you just hand them the original book, it's outdated in certain ways that make it not useful. That, say, go down to your corner drugstore and buy your chemicals to make your little volcano that you burn. Well, you can't really find those chemicals anymore. You can't go to your local photo store because there isn't one.
There were a lot of photochemicals, and you're like, well, if I break open my digital camera, nothing leaks out.
Well, if it open up the batteries enough, something might.
You can't even go to Radio Shack anymore.
So a huge part of it was to update those kinds of things and take out the old mail order addresses and update the dollar price estimates that were in there and sourcing notes. But again, it was really just a matter of making it more useful to the modern audience.
This volcano experiment, it was one that I sort of tagged on as perhaps more interesting than some of the others. It involved 2 pieces of cardboard. The larger will be the larger volcano. 2 small cans, baby food or fruit juice, and plaster of Paris. And then there were some safety notes. Do you recall much about this one?
I do. And actually, I remember seeing this experiment demonstrated. It was actually something that my school did every year when I was a kid in Portland. And it was the chemicals, ammonium dichromate. Am I remembering that correctly? What page are we on here?
173. It didn't list those chemicals as the materials. But yes, ammonium dichromate. This chemical is used for photography and is available in photographic supply houses. Annotation 12. That was true back in the days before digital photography. See Appendix A for current sources.
Yes, and this is a magnificent experiment. Have you ever seen this one demonstrated?
I haven't, but the modern safety practice that starts with this project has chemicals, fire, flying sparks, and toxic fumes just makes me want to go see it right away.
Oh, it doesn't have loud noises, so you're probably all right.
It does not. That's one of the chief differences between this and a real volcano.
Well, and the original safety tips included don't handle the chemicals with your bare hands. People are allergic. Don't inhale the fumes. Don't try to plug the volcano to get an explosion. Any gas fumes that are trapped build up pressure. If these fumes can't get out, they explode. The baby food can would burst, and it could be dangerous. There is no danger at all if you follow these simple precautions. Annotation 11.
See, now...
Wait. Annotation 11. Correct in spirit. However, think it through as well. There is no danger other than the fire-spitting pile of flaming poisonous chemicals.
See, I would have read that, do not do this. And I would have said, okay, this is exactly what I'm going to do.
All over it.
Yeah.
I thought there was no danger thing. What the heck are you talking about? It's
the fire-spitting pile of flaming poisonous chemicals. Was that your favorite line in the book that you wrote?
It's up there, yeah.
Yeah. I liked the volcano. It was probably my favorite one that I read, and I read a good portion of them, but it really isn't the sort of book that you read straight through.
Well, unless you're a kid in 5th grade who's really into that kind of stuff.
Well, then they shouldn't have started with all the chemistry crap because I didn't care as much about that. If it started with the volcano, maybe I'd have gotten all the way through.
On the other hand, maybe you want the kids to be a little bit responsible before they get there.
The kids.
The kids, yeah.
The me.
The you. So this ammonium dichromate, it's this bright orange chemical, catches fire immediately, and it sends out a great rain of sparks, like those videos you see of the Hawaiian volcanoes erupting. And little bits of green ash going everywhere. It's just magnificent.
Seems worth any danger, really.
Yeah, just do it on the beach where there's nothing to burn nearby.
Has the book been what you wanted it to be? The cost-benefit analysis, writing a book is hard. Has it... I'm not going to ask, have you made a ton of money off of it? Because I wrote a book. That's a silly question. But has it been what you want to be?
It has. I don't think that it's plausible to break even on the book in terms of the amount of time that I put into it, in terms of my own career and the things that I put on hold in order to design the book and get it published. It's probably not even quite possible to break even on the cost of what I paid my assistant to work on it last summer. But it
might. I'm still getting checks, so
But I think it was sort of important to me on a personal level to feed this back to the world. And it has sparked a lot of interest, and it also brought out of the woodwork a set of people who I didn't really expect to hear from, which were the people who did have this book in the 1960s or had similar books in the 1960s and wanted to talk to me about them. And that's really charming because it's a relief to hear from these people that not only do they remember this book in the way that I do, but that they are happy to see an honorable update of it.
Has anybody been unhappy that you updated it? I can see people being happy. Yeah.
Not that I'm aware of, no.
Well, that's good. All right. I did not read all of the book because I flipped through and I got a lot more interested in the later chapters, but it was pretty fun. And I have to admit, I'm thinking about getting it for my godsons. I mean, they're just the right age. It's not my house, the light on fire. I think it's perfect. I usually buy Kindle books, though. This one seems to need a paper copy, if only so you can accumulate the stains on it. Do you agree, or would you go for electronic?
I definitely prefer the paper, and I'm not sure I have a great rational reason for that. But I can absolutely see reading novels in electronic format, and I can't really see this being as good in electronic format. Obviously, it is available in electronic formats, but I really designed it chiefly for the paper format, and so much more work went into getting it to look good there.
So going back to Evil Mad Scientist, you do a lot of Halloween stuff over there. Were there any really cool Halloween hacks you saw?
Halloween hacks.
Or projects?
There are always so many great Halloween hacks.
We totally fell down this year. We even used candles in our pumpkins.
I didn't really do anything for Halloween this year, and I feel a little bit shameful about this. I used to be really into Halloween back long before Evil Mad Scientist even, and I used to do extraordinarily elaborate costumes and sometimes redecorated our house to the point it wasn't recognizable for Halloween. But we've sort of accumulated a project library at Evil Mad Scientist of some of the Halloween projects we've done over the last 2 years. A couple of my favorites would be the remote control Dalek pumpkin, and another would be the edible thing in a jar, which is where you go to the grocery store and find all the weirdest things you can get and put them in what look like specimen jars.
I saw that blog post. That was really quite revolting.
Thank you.
Yes. What else?
We've been doing a lot of projects for the last couple of years with candle flicker LEDs, which are LEDs that have a built-in flickering circuit, which is really neat under a microscope. It's an LED, but besides the LED, it's also got in there a little chip, and this is the same sort of thing they did in those old self-blinking LEDs, but instead it's got a little 1 penny microcontroller in there that has a function where it can flicker.
That was actually, we did not get any trick-or-treaters at our new house, which is quite different from our old house where we'd get hordes of them. And one of the things I was thinking about giving out were some flickering LEDs I got from you, magnet and battery, so that they could have candle throwies.
That's a great idea.
But they didn't show up.
More candy for you?
The bag is unopened, which is how it should remain given my love of Kit Kats and Almond Joys. Oh, yeah, that's... so, moving on. Are there any new kits, new projects we should know about for Evil Mad Scientist? Or for you?
We're working on a few different things right now. One of them is a new pen plotter type machine that is going to complement the watercolor bot. And that is an updated version of a machine that's already available called the Axie Draw. But we're working on a new version of that. It's a collaboration. And another is a funny esoteric thing, which is a hack for old electronic knitting machines. So AYAB, or All Yarns Are Beautiful, is a project out of Germany a few years ago to retrofit these old 1980s Brother electronic knitting machines with rather than the original controls, which were punch card based, they now have an Arduino and a shield, basically. And that allows you, through the USB port, to just control this directly like it's a standard computer-controlled robotic tool. And that's an awfully neat thing. And we've been working with them on making a newer version of this hardware. So it's sort of a weird niche market of the intersection of people who like Arduino and yarn. And
hey, we've talked about those things together before. It can't be a null set.
It's not, and it's a fun project to be working on.
Seems like there's a rich field of machines like that from the 80s that were sort of controlled, by punch cards or whatever, but now could be really advanced control with just Arduinos and things. It seems like you could do that forever.
It is, and the knitting machines were a particularly weird set of those because, unlike many of the others, they stopped making them. So they didn't continue their evolution. The embroidery machines continued their evolution, and now you can just buy computer-controlled embroidery machines very easily.
Well, and half the sewing machines have pretty neat embroidery as part of them.
They do. But the knitting machines, these home knitting machines, 200 stitches wide, they just sort of stopped making these these electronically controlled ones. And so...
So when you say electronically controlled, did it go back and forth on its own? My mom had something which I think is similar, and it would click, 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 and then you'd put it all through, and then you'd click it all back, and you'd go back and forth like a weird old loom.
It is exactly like a weird old loom, and these are semi-automated would be the most accurate thing to say. So the basic idea is that you, the human, provide the energy that drives the machine, but the machine has an array of, I believe, 16 solenoids in it that control the stitch positions. So it would take a pattern, which could be from a literal punch card or from a slightly more modernized punch card that was actually sort of a Scantron where you fill in the little grid rectangles with a black pen or print it on a laser printer. But it would take, your stamped piece of paper or plastic and read it through, and each time you do a row of stitches, it would advance one row on the pattern, and you would run the heavy carriage with high friction back and forth from one end to the other, and it would advance the row and so on. And some of them had ports where they had a cartridge that you could program, and you do the program on your home television, sort of like an early video game console. There was a separate thing that hooked to your TV where you could program this. And then some of the high-end later ones actually did have an early computer interface directly as well.
That's just history repeating itself. I mean, the Jacquard looms were instrumental in designing the first computers.
Absolutely.
They were very similar.
Absolutely.
Yeah, we had I don't know whether it was with your parents, but I don't know if you were there. I went and saw a demo of a very complicated loom, and she was talking about the cards and how you design them. I'm like, oh, I could totally do that. And she's like, oh, do you weave? No, I program.
A related thing is actually that auto pen I was mentioning. Those auto pens machines to write somebody's signature, they had a physical moving cam about 2 feet in diameter. And around the outside of the cam, it had 2 edges that it moved little cam followers on that would move the pen in the X plus Y or X minus Y directions. Nowadays, it'd be easy to use a processing sketch to record somebody's signature, use a CNC router to cut out the patterns. Hard to imagine how much different that is than what the old process was for this.
That's what the president uses, right?
I assume the president has one that records your signature electronically these days.
I hope they still use the old one. So I had a book when I was probably early teens that was called Thinking Physics. And
it was really good. I read it last year.
It struck me as the theoretical companion to this book almost, because it was all thought problems in physics. Do you remember that book, or did you come across that?
I don't think I have seen it.
Oh, it's too bad. It was by, I think, a guy named Lewis Carroll Epstein, which is a great name.
Yes.
If you're going to have Lewis, your middle name should be Carroll. But I was just thinking about it when looking at your book. I was thinking, well, this is the experimenter's guide to physics for kids, and that was kind of the theoretician's guide. So,
well, there was more to the title. It was like the Gedonken thing.
Yes, I had it up. I did.
Thinking physics is Gedonken physics. It just makes me wonder what that word means.
It's German for thought problem, I think.
Oh, all right. Well, that's been updated, so I will add a link to that. It was updated in 2002. And it was really, it was interesting to me. It was one of my, I'm going to read nonfiction before bed, and I would go through problems, and I would go to sleep thinking about the problem. Well, yeah, this is how I read nonfiction. If you ask me how I read fiction, it's a lot different. But I was trying to close the show. Right. Windell, do you have any last thoughts you'd like to leave us with?
No, I will probably not update your old favorite book from the 1960s.
That's okay. Alana never needed help. Which is only going to make sense to like 3 of you. Sorry. My guest has been Windell Oskay of Evil Mad Scientist Laboratories. You can get his new book at the Annotated Build-It-Yourself Science Laboratory on Amazon, or you can get signed copies at evilmadscientist.com. We are going to give away a signed copy of his book. Let's see. We didn't really figure out exactly what the contest was going to be, so it's going to be a little haphazard here. Send me your best amateur science disaster, either back when chemistry had real chemicals, or the best science experiment you've seen, and I'll choose randomly from whatever I get. So try that out. How are you going to send it to me? You are going to send it to me by hitting the contact link on embedded.fm or email the show@embedded.fm. So yes, do that, and I will send you this copy that he brought over, and it's signed and everything, and you can start building your own volcano, which is the first part of building the under-volcano layer. You guys are just going to nod and not laugh. Thanks for that.
That just seemed very obvious.
Doesn't everyone know that?
Yes, now they do. As always, thank you to Christopher for producing and co-hosting. And thank you for listening. I do have a final thought. Let's see. How about from Stephen Hawking? That seems pretty appropriate. Apparently he was giving it out advice, and he said, 1. Remember to look up at the stars and not down at your feet. 2. Never give up work. Work gives you meaning and purpose, and life is empty without it. 3. If you are lucky enough to find love, remember it is there and don't throw it away. And now for our shiny new ending. Embedded.fm is an independently produced radio show that focuses on the many aspects of engineering. This is a production of Logical Elegance, an embedded software consulting company in California. If there are advertisements in the show, we did not put them there and do not receive any revenue from them.